I don't even know how to start this one, because clearly it's simply just me talking over these models I designed while investigating wave attractors in internal waves. The instrumentals are clearly distinct from my own vocals, and the beat has been added in to save you from the hindrance of hearing only my voice. And finally, Smooth Global Solutions is the company I have created and have been developing. The animated logo shown here is a regular isotoxal star with 4 points. This inflamed spheroid and the following ring-shaped design you can now see were captured using the same technology used in biometrics, combined with a free-flowing turbulent gas. You can see this here with the flow moving from right to left. Most of the early experiments and research on wave attractors are credited to Leo Mars, who is an oceanographer and shares similar interests to me in waves in stratified and rotating fluids. He taught at Utrecht University before retiring in July 2021. However, not before influencing my interest in the wider applications of geophysical fluids and its widespread applications. Now, I won't be providing you any benefit if I was to delve into the technicalities while speaking over these grand designs. And that's mostly because technical research and teaching resources are available in plenty. You will also notice in these simulations how the geometry of the domain changes over time, but the formation of wave attractors still appears across these domain types, with stratified fluids filling containers that either have one slanted wall or even two slanted walls, while I also provide viewers with new methods for displaying the total energy contained inside the system. This has an inextricable link to the type of geometry containing the fluid, and so by altering the boundary and initial conditions and causing internal waves by exciting the fluid at various frequencies, the energy contained inside the system can be stable or unstable. And there are numerous numerical and analytical methods one can use to solve the system of equations which model this behavior, like in the case where the fluid is contained in a parabolic basin, which is the type of domain you are seeing here. The formation of this wave attractor can also be contained within two horizontal boundaries, such that fluid momentum at the boundaries vanishes, thus preserving the wave attractor inside the parabolic domain. And so, to conclude this first part of my discussion on wave attractors in unusual domains, the unique solutions to the governing system are also provided in the next part. Welcome back to what will probably be my last and final descriptions on wave attractors. In a similar manner to the last part, I will begin with the 4-point star. As most Android phone users will be aware of, this star-like shape is also used as the logo for Google's artificial intelligence application, Gemini. The shape is a regular 4-sided polygon. You can also recreate it by using 4 by 4-sided rectangles. And so, without giving too much more away, I'll move on. In the last part, I spoke about sloping walls and the parabolic basin, where for the latter, I mentioned we will uncover more unique solutions. I will therefore conclude my voiceover descriptions by further reinstating that energy is transported and conserved across the entire domain, which follows from the conservation of energy, since no energy can be lost within the system. Once again, I'd like to thank you all for listening to another one of my videos, and please do continue watching on until the end of this one.